Today, in our second experiment, we are going to verify Ohm's law. For that, we will choose a breadboard first. So from the search section, we can choose a breadboard. Now we will choose a resistor. We can search it from here. Okay, this is a resistor. We can rotate it or can replace it like it is. Okay, I am replacing it. Let's say we are trying to use a 2.2 kilo ohm resistor, so we can change our values from here. Okay, now it's a 2.2 kilo ohm resistor. Now we will need a cell. Suppose we need a 3-volt battery, so we can collect a coin cell of 3 volt. Now I am going to replace it here. Okay, now I am going to connect this positive terminal with one terminal of resistor and the negative terminal with the other terminal of that resistor. So now our very simple circuit has been constructed. So according to our Ohm's law, we know that voltage is equal to the multiplication of current and resistance. So from here we know the value of resistance. Now we will measure the voltage across this resistor, from which we can calculate our current that is flowing through this resistor. Okay, to measure current through this resistor, we'll need an ammeter. So we can choose a multimeter, and with the help of this multimeter we can measure both current and voltage that is flowing through this circuit. First, if we want to measure voltage across this resistor, we are going to connect the positive terminal of resistor with the positive rail of multimeter and the negative terminal of resistor with the negative rail of multimeter. So now if we simulate it, we can see the amount of voltage that is being dropped across this resistor. Here a significant difference we can observe. We're using a 3-volt battery, and according to the parallel rule, the voltage across this resistor should be 3 volt, but we are observing that it is 2.99 volt. There is a difference between the supply and drop voltage, and this difference can be occurred because of the heat loss in this resistor. Okay, so now we can measure the current that is flowing through this resistor. For that we will have to use this multimeter as an ammeter. So we can change its mode by selecting the multimeter. We can change the mode. So I am converting it as an ammeter, and we know that ammeter should be connected in series with the circuit. So now we will replace it in series configuration. So the positive terminal of the cell is going with the positive terminal of multimeter, and the other portion will go in the negative terminal of multimeter. So when we're starting simulation, we can observe that the amount of current that is flowing through this resistor is being displayed in the ammeter section. So with the multiplication of the amount of resistance with the amount of current, we can see that it will definitely equal to or near to 3 volt, and that will be the proof of our Ohm's law.